All right, we're continuing with practice for the test tomorrow. So this is going to be 36 through 41. Number 40 was a repeat. When we get there, I think at number 35, same type of question. So we're looking at trying to identify user-friendly numbers, understanding the geometry also in some instances, but looking for 2 points. And the one that gets this started, there's a vertex here of 8, 9. That's what you're trying to see. You're trying to put the number 8 in, and that gets a multiplication times 0 plus 9. And I think that's pretty easy to do, actually. So identifying this, at least gets you half a point. And the one that's a little bit harder to see, but not much, is 7 over the 4th root of 11. And therefore, we want the 4th root of 11, because that's an easy cancellation. So what makes 11? 8 plus 11, 19. So if we put 19 in, 19 minus 8, it's 11. The 4th root of 11, divided by the 4th root of 11 cancels, and 7 plus 9 is 16. All right, so we'll just work down the board, make some space here. All right, so what do we have here? Well, it looks like a 3 gets us a 7. That's actually the point of inflection of cubic. And there's no real conversion here other than a division by 1 and a division by 1. So we might as well pick the number 4. 1 cubed is 1, times 2 is 2. 4 minus 3 is 1. 1 times 4 is 4. Plus 7 looks like 13. That gets you a check. That's just, a willingness to work with some numbers that you see that hopefully aren't too hard to work with. So what do we have here? We've got a cup shape up, and I can see a 3 gets you 73. I can see the vertex immediately. All right, and also 25. Well, 25 cancels with 25. So what squared gets us 25? God, I hope you're seeing an 8. 8 minus 3 squared, those cancel. So an 8's over here. And if you put in an 8, you get a cancellation. 9 plus 73 is 82. And I hope we're starting to see that I could have gone backwards 5. So minus 2 minus 2 minus 3. Negative 5 squared is 25. What happens to the 25? They cancel. We get 82 again. And you want to make these connections. So that takes care of that one. We have one more. Again, square root function. I can see the number 2, 29. I don't think we can get anything smaller than the square root of 0. Square roots and negatives are imaginaries, and they don't show up on the real number system. Descartes number system here, the real numbers. So this has to be, x's have to be bigger than or equal to 2, and that's domain, which is a fancy name for what can I use? I can only use numbers bigger than or equal to 2. I should say that, because you're going to have to learn what domain and range are. Square root of 7 would cancel nicely with the square root of 7. And I think the square root of 7 happens when I pick an x value of 9. 9 gets me that number. That gets me a cancellation. 4 plus 29, 33. 2 easy points with a little practice. All right. Learning how to factor, learning how to write products. Common factors, 6 and 4, 2's common. Common factors, x squared and x to the 7th, x to the squared. Common factors, y to the 4th and y. Notice I'm taking these smaller, I'll put a 1 there, I'm taking the smaller exponent. I know how to take a 2 and make it a 6, I multiply by 3. I know how to multiply x squared times. Oh, I already got x squared. Y, so y to the 4, I need 3 more. I know how to multiply something times this to get negative 4. I'll multiply it by negative 2. X squared times x to the 5th gets me x to the 7th, and I already have y to the 1. That's the product. Let's practice another one. 24 and 16. Yeah, 2 goes in. 4 goes in, but so does 8. Right? 8 is a common factor. And how do I get 24 and 16? Well, I need a 3 for the 24, and I need a 2 for the 16. X to the 8 and x squared. I think x to the 8 is x squared times x to the 6th. I think that's a common factor of this, so I'm going to take that. And how do I get back to x to the 8th? We just said x to the 6th. How do I get back to x to the squared? By multiplying 8x squared times 2. And I got y to the 20th, y to the 30th. You're picking up on this, you're picking 20. This one's set. This one needs 10 more. And it's just a matter of practice. All right, so mechanically, I'm just going to do the next one. Quickly and easily, hopefully. What fits into 12 and 16? I do believe 4 is the common factor. 4 times what? 3. 4 times what? 4. A and a to the 4th. A is common. I don't have to do anything there. I need 3 more here. I shouldn't have put that there yet because I didn't look at the B's. 8 and 9, I think 8 is common. So therefore, this one's set. This one needs another B. So let's put this a little bit more like that. And hopefully you can see if you multiply this times that, you get that. If you multiply this times that, you get that. One more. Oh, 17, doubled is 34. So I'll pull a 17 out. Don't need to do anything there, but I need a minus 2 here. 8 and 4, I'll take the 4 out. I need another 4. To get a to the 8th. 6 and 8, I'm going to take 2. I'm going to take 6 out. I'm going to need 2 of them here. And I guess I'm set over there. A4B6, A4B6, 17 times negative 2, negative 34. Exponential functions given 2 points and an asymptote. Well, what you want to do is you want to write the numbers. And I'll get some more space for these in a minute. Y2, Y8, 17. I got to make a string of numbers that get me 2, 8, and 17. Well, I think 2 plus 6. 2 plus 6 gets me started. Next time, I'm not going to add 6. No, because I'm going from 2 to 8, and I'm going to 17. And you can look at the exponential videos that show the graphical. I'm just mechanically doing this right now. Okay, so how do I get from 2 to 17? 15. So this is almost it's between a doubling and a tripling function. All right, and I could reduce that fraction. I'm not asking you to. Times 1503, x minus 1503, divided by 97. 97 years it takes to make that exponential change. Now, we can talk about looking at the graphs more carefully. We can talk about domain and range. We can start solving equations, but if you can't mechanically do that, we're going to have a hard time talking about what's going on conceptually. So learn the mechanics and then we'll talk about it until May 15th. All right, let's try it again. I got some more space here, the final frontier. All right, so I've got 3 numbers, -5, 2, and 8. So what do I write? -5, how do I get there? Add 7, next time, don't add 7. How do I get -5 to 8? 13, so this is just a little less than the doubling function. All right, so if I start with an amount like 7, if I start with 7, now it's gonna become 13, and then that one's gonna become 13/7 times 13, just almost doubling. Right, and we start to get that. I said I wouldn't talk concept. I threw a little concept your way. All right, so where was I? Here, all right. 1900, we'll make that time a 0. Anything to the 0 is 1. And then we'll change by 50 because anything to the 1 is itself. You get a cancellation and an addition. All right, so that's that one. Next one. I see 3 y values. I see 4. I see 10. I see 25. So y equals 4 plus 6 takes care of that and that. Next time we don't want 6. We want to go from 4 to 25, 21. This is between a tripling and a quadrupling. Exponential growth. Seems like I'm doing mostly growth and didn't do any decay. Well, that's okay. We'll learn one first. So 2000 has to become a 0. That makes that happen because I know what b to the 0 is, so I have control over it numerically, and I'm changing by 24 units. That's that exponential function. Why don't I do a decay problem here? Let's change 19, something between 8 and 19. Let's make it 12. Okay, so that'll get us a decay. So I've got 3 numbers here by seeing this well. 8, 19, and 12. All right, so we start with 8 is the asymptote. Everything is above it. In this case, how much above it? Looks like 11. Next time it's not 11. Next time it's 8 to 12, which is 4. Okay, that's about a third. Okay, so I'm taking some quantity 11, a third of it, a third of it, a third of it, and we can see that decay to a height of 8. That's what's going on. Now I'm going to make my zeros and ones. 2005, make it a 0. And how much did I change from 5 to 2023? 18 years. So every 18 years that process was happening. All right, let's do another one. Just like the other one. 5, 40, and 59. So y equals 5 plus 35, not 35. 5 to 49, 54. Got something in between, less than doubling. Okay, and we've got 250. So x minus 2050. And it looks like in 50 years, let's make this 101, just to make it look a little different. So in 51 years, that process is taking place. All right, we're using the 0 and 1 linear process for the absolute value. So 3, 7, absolute value measures distance. This one measures distance from the number 3. And there's the distance from the number 3. And I'm starting with some quantity of 7. When I put an 8 in, I get the absolute value of 5. Write an absolute value. And that's positive 5, obviously. How do I get from 7 to 23? It looks like 18 units. 18 and 5, 8, oh, 7, sorry. 16 units. I have the number 5 in my head. All right, and there's your function. Very similar to the quadratic, but the branches are linear, and we'll learn to write that as a piecewise function as soon as we learn to write it here. We'll look at the pieces, because that's how we're going to solve equations, using the pieces. Them pieces. Oh, excuse me. 4, 7, I hope this is starting to come into your mind. I'm measuring change from 4, it's negative, right? V-shaped down. So how do I get from 4 to 0? If I put a 0 in there, I'm looking at converting that calculation, which obviously is positive 4, and I'll erase it in a minute. How do I get from 7 to 0? Remember, I'm starting here. Got to go down 7. That's why this is V-shaped down, the same way a quadratic with a negative is cup-shaped down. But a cup shape is different than a V shape. This has got linear characteristics. So y equals, hopefully you can start to realize that your denominators in these are always positive, and we work from there. All right, another one to practice. Well, 8, 3, I'm just going to do it quickly. X minus 8 plus 3. I know 8 to 12 is a change of 4. 3 to 10 is a change of 7, and I'm done. Next, remember, you're pausing the video anytime you want to stare at something. V-shaped down, I know it's going to be a negative. All right, but I want to nail that vertex. X plus 6 measures change from -6, measures how far we are on the number line from -6. And we're starting with an initial amount of 10. And I know that a 10 to -20 is down 30. And -6 to 1 is a change of 7. Absolute value change of 7 is still 7. And that's your y equals. All right, one more. And 35 is solving a log equation. We already did that in one of the other videos, so we're not going to repeat number 40. -4, -7, absolute value of x plus 4. I drop -4 in, it's 0, and that's the smallest distance you can travel is 0. I put a -7 there, then I look at how do I get from -7 to 20, going up 27 units. How do I get from -4 to 1, going up 5? Absolute value of 5 is 5. All right, now we're doing the same thing, but we're doing it with the quadratic. It's got 2 changes. Oh, no, these are roots. All right, so the roots are x values. Why don't we start from 3 and figure out how far we have to go over and back in order to get to a height of 0. That's what roots are. Well, I think I need to go up 5 units. But if I'm multiplying by 2, because an a is the multiplier of the squaring process, then I only want half of that. And if I'm squaring, I better start with a square root. In other words, it's a 5-second question. If you look at the 3 numbers here, they are the same 3 numbers there, and you have to sort out what's going on. And I will do this one out a little bit more, and then just mechanically write the answers. All right, an a value of 2 means I could have said 2 times measuring squared change from 3. That measures square change from 3 with an initial amount of -5. And I want to know when that equals 0. Okay, I hope you see that something -5 equals 0, that something has to be 5. So that takes us to moving the 5 to the other side. And 5 is part of your answer. Now, if you're doubling something, and that is the rest of it here, x minus 3 squared, and you want 5, then this better be 5 halves. That better be 5 halves. Oh, that's part of your answer. Oh, so I guess we divide by 2 and move the 2 to the other side. And I guess if something squared equals 5 halves, then you better have the plus minus square root of 5 halves in the box, because the squaring gets rid of the plus minus and the square root. So I hope that makes sense, that we isolate x minus 3 with a plus minus square root. And if something minus 3 equals 0 or equals that, I think we got to add 3. Not quite sure I finished it up quite the way I wanted to, but I think you can see that the answers are right in front of you if you put the effort into seeing it. If you put the effort into seeing it, you can do this one effortlessly. All right, 2 is above 0, so I have real roots. I'm starting to measure my x's from -7. Plus minus the square root of, looks like I got to go down 2, and I'm dividing by -3. I got to go down 2, and I'm dividing by -3. You know, negative and a negative gets me real roots. -7 plus or minus 2/3. And again, you could always have written this as -3 times x plus 7 squared plus 2, setting that equal to 0, cup shape down. My initial amount's bigger than 0, I got real roots. So subtracting 2 and dividing by -3, subtracting 2 and dividing by -3, that's why it's positive 2/3. Undoing squaring gets you the plus minus. That gets rid of the squaring. +7 becomes -7. And I think we could have done that without having to do this. All right, so I'm going to do that for the next 3 problems because I got some other work to do before classes start today. So I'm going to measure from -9. Plus minus. Okay. Ooh, imaginary roots, right? Because 50 is way above 0. So I got imaginary roots, so I'm just gonna write that with an imaginary over here. And I've got to do what? Put a 50 divided by 3 in there. All right, well, that was our first imaginary one, so let me show you why that's true. So 3x plus 9 squared plus 50 equals 0. All right, first step, subtract 50, divide by 3, negative 50 over 3. Next step, plus minus the square root of 50 over 3i, and you can see that part of it, okay? And positive 9 becomes negative 9. Okay, so you want to know if the roots are real or not. So ask yourself the question, do I have real roots in this problem or not? Well, to answer that question, you got to look at the y value. And what are roots? Equaling 0. That altitude is bigger than this one. You have imaginary roots again. So you can put a plus minus square root with an I at the end. And you're just dividing 5 by 2. And measuring from 7. There you go, you're done. If you really understand the process, you know that you've got to go up 5. You know that you're dividing by a negative 2. Well, there's your imaginary situation right there. Okay, and you're squaring, so you got to do the inverse with plus minus. Okay, you're trying to do some thinking here. Do we have real roots over here? Looks like we do. I got to go up 21, I'm dividing by 3, I'm taking a square root and I'm measuring from negative 4. And again, you could have written this as x plus 4 squared minus 21 with a multiplier of 3, setting it to 0, minus 21 becomes positive 21. Multiplying by 3 becomes dividing by 3. Real roots. Squaring becomes plus minus square rooting, and minus and positive 4 becomes minus 4 on the other side. And I will actually show this one. I'll show the answer. 3 times minus 4 plus minus the square root of 21 over 3 plus 4. Right? Squared minus 21. So I put in the answer. What happens to the 4s? Cancel. What happens to squaring a positive and a negative? You get a positive. What happens to squaring the square root of 21 over 3? You get 21 over 3. What happens to multiplication by 3 and division by 3? We've done the squaring, we've done that. And what's 21 minus 21? A height of 0. Okay, so minus 4 plus the square root of 21 over 3. Square that number and multiply it by 3. And you're going to hit 0. And same thing happens to the left. Woo, I'm out of breath. All right, that takes us up to 41.